Hey guys, welcome back to Unit 9, Day 7. This is Special Right Triangles, and today we're talking about the 30, 60, 90 right triangle, which is this right triangle right here. You'll notice both of these circles have the same triangle in them. They have a radius of 1, which is why we call them the unit circle. They're just laid out in different directions because you should know that the sum of the three angles in your right triangle have to add up to 180 degrees. So if this one is 30, we know this one is 90. Therefore, this one has to be 60 because 30 plus 60 is 90, plus the additional 90 is 180. The same thing will be true about this triangle here. This is 60, this is 90, this has to be 30 because 30 plus 60 is 90 and the additional 90 makes 180 degrees. Really, the difference between these two is which angle we determined will be as the central angle. So I'm just going to erase all this. I don't want to confuse anyone. The last special right triangle is the 45, 45, 90 right triangle. Same reason. This is 45 and 45, add up to 90, and a 90-degree angle. So if this triangle were drawn the other way around, moving the blue 45 here and the black 45 here, we would just get essentially the same thing. So there's only one way to draw a 45, 45, 90 right triangle. And again, in this case, our radius for each of our circles here is 1. So this radius is 1 unit. So let's take a look at our do now assignment. So if you were to do this in the class, your do now assignment would be to find the measure of x and y using right triangle trig for the 30, 60, or 45 degree angle for your central angle of theta. So there's a little typo here. This is supposed to say 60, and this one over here is supposed to say 45. Pretty much I mixed them up. They don't match up with the triangles they are with, so please correct those. Firstly, if I want to find the measure of side x, that is this side from this angle, we only know this side is side 1. So we're going to label this side the hypotenuse. 30 is not the opposite. X is not the opposite of angle 30. Y is, so this is the opposite. But we're not looking for y right now. We're looking for x, which is the adjacent. So we are using these three pieces, this angle, the hypotenuse, and the adjacent. So we're going to write a trig ratio to find out what that is. So SOHCAHTOA is what we use to find sides and angles of right triangles. So we have the adjacent and the hypotenuse, so that's cosine, right? Because we have an A and an H here, whereas TOA does not have an H and sine does not have an A. So we're going to write our trig ratio now. So the cosine of a 30-degree angle is equal to the opposite, the adjacent side, which is x, over 1. Now, the reason we're using the unit circle is specifically to make this 1. So we pretty much could have written that cosine of 30 degrees is equal to x. So next to x, I'm going to write cosine of 30. The same thing would have been done regardless of whether or not the angle is 30. It just would have been cosine of the angle. So x is always equal to the cosine of the angle. In this case, the cosine of the angle is equal to 0.866 if you use a calculator, approximately, rounded to the nearest hundredth. And because it doesn't really matter what the angle is, if we're using the unit circle, it's always going to be cosine of x over 1. So this coordinate here is going to be x units to the right. So we call that x units to the right. It can also be referred to as cosine of the angle for the x coordinate of this point on our circle. We're going to do the same thing to find the measure of side y. So side y, we're going to be doing it with, well, we need the opposite side, and assuming we didn't find x, we would use the hypotenuse in this case, so that's 1. So we have the opposite and hypotenuse, which is sine, so we're going to do this with sine. So the sine of 30 degrees is equal to y over 1, because that's the opposite over the hypotenuse. Again, because we've chosen to use the unit circle, it's just sine of 30 degrees is equal to y. So wherever we have y on the unit circle, we can call that sine of 30. And if we do our calculator for that, we'll get 0.5. So back to our unit circle, this point is going to be xy, because it's y units up, and the y coordinate can also be written as the sine of theta. All right, so the things we need to know is that the coordinate where the point intersects the unit circle at a right triangle formed by a central angle in standard position is going to be the point xy, and that can be found doing cosine of the angle or sine of the angle. But again, this is only for the unit circle, so the radius has to be 1. Now, the tangent of 30 is going to be equal to the opposite side, which in this case is y, divided by the adjacent side, which is x. So in this case, that would be 0.5 divided by, excuse me, let me fix that, 0.5 divided by 0.866, and just going to use my calculator for a moment, 0.577 approximately. And that's how we find the sine, cosine, and tangent of 30 degrees using the unit circle. So we're going to apply the same things to find it for 60 degrees. So the cosine of 60 should be equal to 0.5. As we've addressed before, that the sine and cosine values for the two different angles in a triangle are the opposites. So the sine of 60 should be equal to 0.866. And the tangent of this should be the y value over the x value, or 0.866 divided by 0.5, which if I use my calculator real quick, which is just next, is equal to 1.732. All right. The last triangle, if we were to do the same thing, the cosine of 45 is equal to 0.707. The cosine of sorry, not the cosine, the sine of 45 is equal to 0.707, and the tangent of 45 will be equal to the, once again, y over x, or the sine over cosine of 45 over 45, which in this case both happen to be 0.707 is going to equal 1, because any number divided by itself is 1. One of your part assignments that you'll have to do for your practical application is to set up the trig ratios for both the 60-degree triangle and the 45-degree triangle. The next part of our assignment is just to do some calculations. So we're going to evaluate the following radicals to the nearest thousandth using our calculator. If I were to use my calculator on radical 2, I should get 1.414. Now that number doesn't match any of the numbers from above, but the other ones all are going to match some of them. Radical 3 is 1.732, which you'll notice matches tangent of 60. So every time you see 1.732, you can write radical 3. Radical 2 over 2 is equal to 0.707. So every time you see radical 2 over 2 or 0.707, you can write radical 2 over 2. These are exact values, whereas the decimals were actually approximations. Next, radical 3 over 2 is equal to 0.866, which you'll see we also have popping up several times. So radical 3 over 2 is also the sine of 60 as well as the cosine of 30. So every time you see 0.866, you can write radical 3 over 2. And lastly, radical 3 over 3 is equal to 0.577, which you will notice is equivalent to the tangent of 30. So the tangent of 30 is actually equal to radical 3 over 3. I'm sorry, yeah, the tangent of 30 is equal to radical 3 over 3, and the tangent of 60 was equal to radical 3. None of them were equal to radical 2, and you'll see why that is in a moment. Now that we're familiar with these common decimals and radicals, every time we get these decimals using our calculator, we can write the equivalent radical. So sine of 30 is equal to 0.5, which there's no equivalent radical for. The sine of 45 is equal to 0.707, so I know that that's equal to radical 2 over 2. The sine of 60 is equal to 0.866, which I know is equal to radical 3 over 2. That's pretty much what we're doing here. We're just writing the appropriate radical when we get a particular decimal. You can finish the remaining 6 examples of these on your own, and then we will turn to the back to look for some patterns. onto the back, there are patterns as to why these values are what they are. Now, it's important to note that 30, 45, and 60 are the common reference angles we're going to be using to evaluate trig functions. Now, 0 and 90 technically can't be reference angles because they won't form triangles at all. If your angle in standard position is at 90 or 0, they'll actually just form straight lines. Now, those values still follow the same pattern, so I'll include them on this list, but we'll be talking about 0 and 90, 180, 270, 360, and all multiples of 90 for tomorrow's lesson. So some patterns to notice. If you just remember these key numbers, which is 0, 30, 45, 60, and 90, sine just follows this pattern. It's radical 0 over 2, which we're going to simplify is just equal to 0. Of 30 would be radical 1 over 2, which is just 1 over 2, or 0.5 on your calculator. Radical 2 over 2, it doesn't simplify because radical 2 is not a simplifiable number. That's going to be equal to 0.707 on a calculator. Radical 3 over 2 doesn't simplify either because radical 3 is not a perfect square. We'll get 0.866 approximately. So every time that comes up on your calculator, you can write that. And for the sine of 90, you get radical 4 over 2. That's 2 over 2, which is equal to 1 because any number divided by itself is 1. And if you notice the cosine values, because the opposite and adjacent switch in cosine and sine, their values work in reverse the other way around. So this one is 0, this one is 0.5, this one is 0.707, this one is 0.866, and this one is 1 for all the exact same reasons that sine were these values. Now, as we saw before, tangent is equal to sine over cosine because it's equal to y over x. So we're just going to go over how to find the tan values, although our focus today is not actually on the tangent values. For instance, let's just do, we'll do the first two, and then you can do the remaining 3 on your own. Now, if we were to do the sine of 0, that's 0, divided by the sine of the cosine of 0, which is 1, we get 0. That should be pretty easy. So therefore, the tangent of 0 is 0. If we were to do the tangent of 30, this one's a bit harder. We actually get 1/2 divided by radical 3 over 2. Now there's no like easy pattern for remembering tangent, even though we had a very easy one for sine and cosine. We have to know how to deal with complex fractions. So this is going to be equal to 1/2 times 2 over radical 3, because this is a division of 2 fractions. It's keep, change, flip. We're going to cancel out the common factor of 2 and multiply, so we'll get 1 over radical 3. But we're not allowed to write that value because this has an irrational denominator. To make it a rational denominator, we're going to multiply the numerator and denominator by radical 3, because radical 3 times radical 3 is going to equal 3, and 1 times radical 3 is equal to radical 3. So this is where the radical 3 over 3 came in the previous set of examples. For the next one, radical 2 over, let me use a different color just to avoid any confusion. Radical 2 over 2 divided by radical 2 over 2 is just equal to 1, because any number divided by itself is 1. For the next one, we have radical 3 over 2 over 1 over 2 is going to equal radical 3 over 2 times 2 over 1. Keep, change, flip. The 2's cancel out. It's just radical 3 over 1, or radical 3, which should explain why radical 3 was relevant. You'll notice none of them gave us radical 2. And lastly, we have 1 over 0, which is just undefined. So that's where the common trig ratios come up for tangent. If you see these in radian measure, these are the radians that correspond with each of these degrees. So pi over 6 is 30 degrees, pi over 4 is 45 degrees, pi over 3 is 60 degrees, and pi over 2 is 90 degrees. On to the final part of today's lesson. It is how to evaluate any trig ratio who has a reference angle of 30, 45, or 60. So we're just going to pick one of the problems from down below. It doesn't matter which one. For just picking one in the middle, I'm going to pick cosine of 330. So these are the things you need to know. You need to know the reference angle, assuming it is either 30, 45, or 60. And you need to know the quadrant that the angle terminates in. So 330 degrees, taking it to the set of axes here. This is our angle in standard position. We're going to rotate around 330 degrees. That's right around here. So our angle terminates right here. The angle here was 330, rotating around this direction. But the reference angle is the angle formed here inside of the triangle with the x-axis and our terminal ray. So our angle here is 30 degrees. And that's because 330 plus the remaining 30 will make 360 degrees. So where we have cosine of 330 can actually be simplified to a form of cosine of 30 degrees because the reference angle is 30. Now, to figure that out, we have to determine what sine the cosine function is in this quadrant. So each of the quadrants has different values that are positive and negative, and that is that all the trig functions are positive in quadrant 1, because in quadrant 1, our triangle is going to have a positive y value and a positive x value. Therefore, either you're just using the sine value, which is y, which is positive, you're just using the x value, which is cosine, which is positive, or you're doing one over the other for tangent, which is positive. So all the trig functions are positive in quadrant 2. Whereas in quadrant 3, this value, the x value, is actually negative and the y value is positive. For that reason, sine, which is just positive, will be positive in this quadrant, but cosine will be negative in this quadrant. So sine is positive in quadrant 2, but cosine isn't because the x value is negative. And tangent is also negative because you have a positive divided by a negative, which will be negative. So in quadrant 1, all the trig functions are positive. In quadrant 2, only sine is positive. In quadrant 3, just trying to get a different color. If we had a triangle here, the reference angle would be here. We have a negative x and a negative y. So sine would be negative because we have a negative y value. Cosine will be negative because we have a negative x value, but tangent is actually positive in this quadrant because we have two negatives, and when we divide them, we'll get a positive. And in the last quadrant, cosine is actually positive because the x value will be positive in this quadrant, but the y value will be negative. So you need to know your quadrants. And one of the mnemonic devices a lot of people use is all. So I'm just going to circle these as I go. All, meaning in quadrant 1, all the trig functions are positive. Students, meaning in quadrant 2 that only sine is positive. Take, all the tangent is the only positive trig function in quadrant 3. And calculus, in quadrant 4, only cosine is positive. So it's all students take calculus. Not saying it's true, saying it's a way to remember the quadrants. It's ASTC, going from quadrant 1, 2, 3, and 4. So because we have a reference angle of 30 and cosine is positive in this quadrant, we can rewrite this as positive cosine of 30, which is equal to positive, the cosine of 30 is radical 3 over 2. If we did sine of 330, that would be negative because sine is negative in quadrant 4 because radical 330 terminates in quadrant 4. So it'd be negative sine of the reference angle, which we said was 30 degrees. So that would be negative 1 over 2 because the sine of 30 is 1 over 2. The same thing can be done for all of the other examples, so try them yourselves, and if you have any questions, make sure you ask them in the comments or on Google Classroom or on PupilPath.